All right, welcome back. And now let's talk about one more aspect. So we talked about the compound interest formula, which is A equals P times 1 plus R raised to the T power, right? Where T is the number of years and R is the annual interest rate. Now, this is based on annual compounding, right? So, what if we want to compound differently, right? So there's all kinds of different ways of compounding this. We can compound annually, we can compound quarterly. So what we want to do is we want to be able to modify this formula so that it includes any kind of compounding, not just annual. So what we do is, what if we wanted to compound the interest rate monthly? How would we do that? Well, we would need to come up with a monthly interest rate, right? So how would we do that? We would take the annual interest rate, R, and we would divide by what? 12, right? And then now if we're compounding it every month now, that means time can't be in years. We have to look at the number of times that it compounds. And since it's monthly, we want to be able to say, okay, what are the total number of months, right? So we'd have to take N times T, the number of years, times 12, right? So we would take the number of months in a year, 12 times T, the number of years, and that would give us a total number of months over the investment time period. What if it was like annual, right? What if we wanted to, or not annual, daily? Well, in that case, we would have to come up with a daily interest rate. So we would take R and divide by what? 365. But then our time would also have to be in days. So we'd take the number of years, T, and multiply it by 365. And this is where we start talking about the number of compounds per year. And so let's talk about that for a moment. So if we look at just thinking about number of compounds per year, in annual compounding, that would just be 1. In quarterly compounding, we just ask ourselves, how many quarters are there in a year? So that would mean the number of compounds per year in quarterly case would be 4. Semi-annually, that means there's 2, right? Every 6 months. Bi-weekly, if we compound bi-weekly, that means every 2 weeks. And since there's 52 weeks in a year, it would be half of that. So this would be 26. Weekly, like I just said, would be 52. Monthly, as I said just moments ago, 12. And daily would be 365. Now, this is what we call the number of compounds per year, and we just represent that as N. So what we're going to do is, remember what I said. We're going to take the annual interest rate and we're going to divide by the number of compounds per year. So we're going to change that to 1 plus R divided by N. And then of course T, we're going to have to change that so that it represents the number of months or the number of weeks, whatever, number of days over the time period that we're interested in. So this would become N times T. And so this becomes the new compound formula that can handle any kind of compounding. Okay? And I think, is that where I want to stop? Oh, one more thing. So now, look at this. Okay, so now we have this, right? Now, if I take this and I say, okay, well, let's look at it a little differently. Let's take this, and inside we'll do 1 plus 1 plus R over N raised to the nth power raised to the power of t Okay? And let's, oh, how do I want to do this? Notice how this here looks like this. 1 plus 1 over x raised to the x power, right? So what if we said that the interest rate was 1%? Or excuse me, 100%. Okay, that would mean that r would be 1. So if we assumed r was 100% for this here would go to e, right? So what happens here is if we ask ourselves, hey, what happens to this as n goes to infinity? Well, this will become a equals p times e to the rt. Okay, and so this formula is the formula that handles what we call continuous compounding. So in a problem, you'll either be given annual, quarterly, weekly, you'll be given some sort of compounding, or you'll be told that the compounding is continuous. If it's continuous, you have to use this formula. If it's some other type of compounding, this is the formula that you'll use. All right, have a great day.